So, welcome to today's webinar. This is already our fourth webinar, and today we'll be dealing with a technical issue and more particular on soil and top layer conditioning for sports turf construction. But the majority of the things I will be addressing is also, you can also apply that to other applications because this is not plant specific. I will be talking about soils. So I will show you how we can improve the soil physical properties using TerraCottem. And for the majority of you, this will be a refreshment course. But I think, and both Carol and I thought that would be important to repeat this. So for sand, for soil and top layer conditioning, we all know that sand is very important in sports turf construction. I will show you why. But also important, what exactly is soil conditioning? A second part of the presentation, we know that sand has benefits, but I will show you the limitations of sand and how can we address these limitations using TerraCottem correctly, so the good application rate, the correct application depth, some practical applications like renovation of goal mounts, hybrid system, and also other sports fields. After the conclusion, I will show you some recent results we've gathered from a master thesis finished at University of Ghent. This will be new for you. So why sand? We all know that sand is a necessity in top layers. If we want to construct a high quality pitch, we need sand. Also, the correct sand is important. I won't go into details here, but when you have a new project, you also have to look at the description of the sand because you have different types of sand: bigger particles, smaller particles, round sand, rectangular sand. So it's also important. Benefits for sand: we all use sand because it allows high water percolation and it is not vulnerable to compaction. But it has shortcomings in a physical, biological and chemical way. It lacks structure, it has a low retention for water and nutrients, and it's basically an inert material. So we need soil conditioning. During our Sister4 project, we helped to develop a good definition for soil conditioning, because what exactly is soil conditioning? Basically, it's all products incorporated in the soil that improves the soil physical and soil chemical features, and it compensates those characteristics which can be limiting for plant development. So sand allows high water percolation, and that's a requirement because we play football during winter times. I think this is true for both northern and southern hemisphere. So we play football during the winter period where we have excess water. The plants don't grow well during winter time, so there's a low transpiration rate for coming from the plants. Also, temperature is rather low, so evaporation is low, and we have high amounts of rainfall. And because of global warming, this is even more and more true now. We get drier summers and wetter winters. So we need to get rid of this water. That's why we use sand. This graph shows you the effects on the x-axis of all particles that are non-sand particles, so basically clay and soil and silt particles. And on the y-axis you see the Ks. The Ks is a saturated hydraulic conductivity. It's a rather technical term, but it's basically a value showing you how much water is transported through the top layer. So the more smaller particles, so the more non-sand particles, the lower this Ks value. In Belgium we have criteria for that. When we construct sports turf, we say we need more than 90% of sand, and this graph shows you why. So for example, if you have 8% of particles in your soil that are non-sand, you get a hydraulic conductivity of 28 millimeters per hour. And to give you an idea, 28 millimeters per hour. This means 28 liters per square meter of water that can be transported through the top layer. If you increase the silt content only by 2%, this value drops to 19 millimeters per hour, so 19 liters per square meter. This doesn't sound much, but if you think about it, that's 1 bucket of water per square meter that's less transported through the top layer. So that shows you how important it is to have a high sand content in your top layer. A remark I want to make, also organic material has the same effect. The more organic material in your soil, the lower the KS value. We also know that organic material is important. It improves water retention, it improves soil structure, but you can't add too much organic material. The same criteria that we have specified mention this. We say we can only add 2 to 3% of organic material, and in really sandy soil, so up to 95% of sand, we can increase it up to 5%, but that's really the maximum. So these criteria, we have a website for that, for these criteria. At the moment this is only in Dutch, but we are making an English one. But after this webinar, I will send you a link where you can download an English summary of these criteria. And if you're interested, you can have a look at it. These criteria are based on my master thesis I finished in 2000. So basically what we want to avoid are things like this. We don't want sand, and we don't want water, we don't want to play in mud. Is this an exaggeration? Yes, most likely. But remember, last year a very important qualifier for the Copa America tournament was postponed between Argentina and Brazil because you have standing water on the surface. This is a picture I found on Twitter. On the front you can see an artificial pitch based on a really hard top layer, and in the back you see a natural sand-based football field. So you can see the effect the composition of the top layer has on water infiltration. Why does sand has a really high percolation rate? It has large pore spacing in between the sand particle. This is a microscopic image of sand. But because it has that much pore space, it cannot retain the water. So that's actually a physical limitation for water. I will now show you how water is held in the soil. This is a short movie, and if you put a sponge in the soil in water, it will drain water. So water is retained by the suction force of the soil. You can compare it. If you increase the suction force, so if you tilt the sponge, water is coming from the sponge. If you further increase the suction force in the soil, so if you further tilt the sponge, more water is taken from the soil, or in this case from the sponge. So this shows you that not all water in the soil is available for plants. The higher the suction force of the soil, the less water is made available for plants. And this is a graph that shows you that. So on the x-axis you can see the water content in the soil, and the y-axis you see the suction force. So the force that is coming from the soil, and that's actually taking water from the soil. So the higher you go on the y-axis, less water is available in the soil. This is a typical shape for a PF curve in a sand soil. A clay soil has a shape like this, and of course a loamy soil is something in between. And this shape of the PF curve is very important, because imagine you have a rain shower and you have a lot of rain and the rain stops. A lot of the water in the soil is now draining and going to the drainage system. So at a certain point, and that's called PF2, that's field capacity, there's an equilibrium in the soil. No more water is going to drainage. So if you see, and for a sandy soil, That means that only 7% of the water in the sandy soil is actually retained by the sand. So all the rest of the water is simply draining away through the drainage system because there's gravitational force pulling on it. So only 7% of water is available at this point in time. If the suction force increases, that can be due, for example, because there's evaporation, water is taking sand because it needs it to grow. So you go up in the y-axis. At a certain point you reach PF 4.2, and that's called the wilting point. This is another equilibrium here, because the force here at this time is higher than the suction force from the roots. So the water above 4.2 is not available for the plants. So out of the 7% I showed you, 2% is not accessible for grass roots. That means that you only have 5% of plant available water in a sandy soil. So that's not a lot. Look at the shape of the clay soil. Because of this shape, you have 22% of plant available water in a clay soil. So it's much higher. Now, what's the effect of TerraCottem turf or TerraCottem universal you can also use TerraCottem universal, but what's the effect of TerraCottem turf? It tilts the PF curve to the right, and the word tilt is here very important. It does not shift the PF curve to the right, because otherwise the difference between PF2 and PF 4.2 would remain the same. It tilts it to the right. So at field capacity you have more water, and at wilting point there's again more water, but the difference is bigger. So instead of having 5% of plant available water, you now have 25% of plant available water. So the same soil, but with TerraCottem turf. Why is that? We all know that the water retention capacity of TerraCottem turf is over 400 grams per 100 gram of TCT. That means that 100 gram of TCT can absorb 4 liters of water. But because the PF curve tilts to the right, almost all water inside the polymers is plant available. And we have an analysis done on this, and we know that almost 97 to 99% of the water inside the polymers is available for the plants. So that's why it's possible to even grow on 100% sandy soils. You can have good grass development. This is an aerial footage of a pitch constructed with TerraCottem turf, the same soil next to it on the top of here in this picture without TCT. So you can clearly see the difference. This is the lawn in front of our factory house during 2015 heat wave. So the lawn here is actually a typical Belgian soil, and the grass is really suffering here because it didn't rain for 2 weeks or so, and the temperatures were really high. But what's interesting, in the middle of our lawn, we've constructed a demo box, and this demo box is a sand-based top layer with TerraCottem turf, and we use this demo box to take samples for exhibitions. So even though the soil here is it can't retain the same amount of water as the natural soil next to it, because we've added TerraCottem turf, the grass is growing much better, and it's withstanding the heat wave very well. A second limitation for sand, it lacks structure. We have all been to the beach, and we know that, basically there's no structure in the sandy soil. You can compare it, for example, with a bucket of marbles. When we were children, we all played with marbles. If you have a bucket of water, of marbles, and you try to squeeze your fist into it, it's not possible because it's very strong. So it doesn't compact, but it remains a pile of marbles stacked on top of each other. That's the same for sand. So it has no structure at all. If you add TerraCottem turf, and I think you've all seen these pictures, on the right you see a sandy soil with TerraCottem turf. And when we took this sample, the structure remained intact. So we've got a really good soil sample. In the middle, the same soil, but without TerraCottem turf. So when we took the sample, all the loose sand simply fell away from the sample. So it lost its structure. And to show you a typical Belgian root zone on the left, this is what we play soccer on. So it's a high clay content, so it's really compacted, so you don't see good root development. So if we want to play during winter time, we need sand in the middle, but if you want to have structure, you need TerraCottem turf. On the right, you can see it here. Recently we've applied TerraCottem turf to King Abdullah Stadium in Saudi Arabia, and the contractor was really pleased, and that's one of his key things he said to us, that the structure of the soil was really well developed because he've added TerraCottem turf. The importance of application rate and application depth. From top to the left, you can see here increasing amount of TerraCottem turf. So the more TerraCottem turf you add, the better the root development. Of course, this will be also a money issue here. At a certain point of time, the investment will be too high, so you need to find a good balance. So that's why we normally say 120 grams per square meter. Similar pictures, the importance of application depth. So the deeper you apply TerraCottem turf, the deeper the root development, which makes sense. Most roots grow in a top layer to 20 centimeters. That's why we say 20 centimeters, 100 grams per square meter. That's a good application rate. When you place sods instead of seeding, this is also very important because you get faster establishment of the sods. This is a small demo plot we've done. We've placed sods on a really sandy soil, and we went back to the same plot 2 weeks after, and we tried to lift those sods. And as you can see in this footage, it's nearly impossible to lift the sods. So you get really fast and good establishment. And this is not limited to cool season grasses alone. This is a picture from Morocco with the warm season grass, paspalum. Again, really good grass development. And finally, the third limitation of sand. Remember the microscopic image I've shown you. Sand is inert. The comparison I've done with marbles is actually a really good comparison because marbles are silica. Sand is also silica. So if you compare it with clay, you can see here at the bottom, clay has another structure. It has a plate structure or it has a tubular structure. So that's why you can store a lot of water here inside this soil. It has a really big surface area. And also the surface area is negatively charged. It has an electrical charge. That's why clay can also absorb nutrients. Sand cannot do that. This value, the CEC value, is a value addressing this issue. The higher the cation exchange capacity, the higher the amount of positively charged ions can be absorbed by the soil. If you look at it, sand does not have an electrical charge, so it doesn't have a high CEC value, so it's not a fertile soil. Clay is much more fertile. That's why a lot of agriculture is done on clay soil, because it basically is a really fertile soil. And that's the reason why you add organic material to the soil. You want to increase cation exchange capacity. But remember, you cannot add too much organic material because it will limit water percolation. The cation exchange capacity of TCT, you can see here in the green arrow, is in the same line as organic material, but it does not have the disadvantage of decreasing water percolation. And why does CEC has such a high cation exchange capacity? It contains polymers, and this is the blue arrow here, with a really high cation exchange capacity, but also it contains zeolite, and we've selected our zeolite because it also has a good cation exchange capacity, and that's the gray arrow here. So finally, also TerraCottem turf contains the fertilizers and the root growth stimulators. We all know that. So on really infertile soils like sandy soils for sports turf, it's possible to have good root development. Cool season grasses, warm season grasses. This is soil conditioning. It's not limited to climates or species here. We are improving the conditions in the soil. This is a demo, a small demo. On the left you can see a pure sandy soil with TerraCottem turf. On the right you see the control. And this green groundsman for Bayer Leverkusen, before he purchased TerraCottem turf, he wanted to find out itself if everything we were telling him was actually true. And he was astonished by the results. And as a result, he added TerraCottem turf in his training facility with a really good result. In Belgium, also in Holland, we use a lot of TerraCottem turf for the renovation of goal mouths, because this is the area that's suffering the most during football matches. So if you want to have a stronger area there, you can add TerraCottem turf. Also, hybrid systems are really a trend now here in Europe. They are further increasing the sand content of the soil, so it's almost 100% sand, because they want to get rid of the water, and they are reinforcing this sand-based structure by adding small amounts of artificial fibers. There are different systems. And in between the artificial components, they are seeding natural grasses. But because they have good results in winter, but in summertime it's suffering because you have the high temperatures and the low rainfall, a lot of these systems are standard applying TerraCottem turf. Everything I've mentioned to you is not limited to sports turf alone. You can oval, so multi-surface areas, private lawns, golf courses, baseball fields. This is true for all these kind of applications. So to conclude the first part, we all know sand, we need it, it's a necessity. It has certain limitations, but all these limitations can be amended by using TerraCottem turf. Now, and to conclude the seminar, some recent results. A Belgian student, Leonard here at the University of Ghent, did a study on the suitability of different soil conditioners that are commonly used here in sports turf construction. So he has compared organic, inorganic soil conditioners, mixed soil conditioners like TerraCottem turf. He did a trial in a greenhouse under controlled conditions, so artificial lights were applied, temperature was maintained at a high level. All containers here received the same fertilizer regime, so only the effect of the soil conditioners was compared. Effect on plant growth, but also important for us, I will tell you later on. These were the parameters that were investigated, so grass and root growth. He looked at the water use efficiency, what plant available water, soil cover, microbiological soil life, and other physical features like bulk density and saturated hydraulic conductivity. But also important, he looked at pricing. What are the unit prices of all these soil conditioners, and more important, application prices? Because if you apply TerraCottem, you only need a small amount of TerraCottem, If you add, for example, organic material or zeolite, you need a much higher quantity. So even though the unit price can be cheaper, application price can be higher if you use those products. This is a summarizing table showing all parameters that were investigated on the first row. You can see it here. What is colored in green was a positive effect, and you can see that TerraCottem turf had an overall positive effect on all parameters investigated. Soil cover was neutral here for all soil conditions because there was an error in the software that was analyzing the digital pictures, so there was no real conclusion here. But overall, a positive effect of TerraCottem turf. Some figures. Biomass production was increased by over 200%. So he gathered the clippings coming from the grass, he weighed them, and he has seen that biomass production was doubled. Root growth 250% higher. Water use efficiency 50% higher. Also important, microbiological soil life was increased, so healthier soil. Saturated hydraulic conductivity, that was the first graph I showed you, also increased. Water retention increased by 85%. Cost-benefit analysis. On the left you can see the application price of adding TerraCottem turf. If you compare it, for example, with zeolite and lava, application price is much higher. And remember, TerraCottem turf had a better effect on plant growth. So that's for us as a sales point of view, this is very important. The red and the black crosses you can remove here from the equation because those had a negative effect on plant development. Also, other maintenance jobs that are commonly applied when you construct football pitches, for example, price of seeding, price of sodding, average maintenance cost, soil heating. So you can see the price of TerraCottem is actually not an issue. If you are creating a sports turf construction, remember the hybrid systems, that this is the price of a hybrid system, the second from the bottom. If you add TerraCottem turf, it does not change the pricing of your overall project that much. Now, zeolite, to make the comparison with zeolite. Zeolite is commonly used here in Europe as a soil amendment for sports turf construction. In Leonard's thesis, he has used our zeolite, so it's actually a good zeolite. Our zeolite was selected over more than 50 other zeolites coming from all over the world. So it's actually a good zeolite in this comparison. And I will show you the difference between TerraCottem turf and a pure zeolite. This is the effect on biomass production. The fourth column is the normal application rate of TerraCottem turf. The last column is a double application rate. So you can see the much higher effect on biomass production by adding TerraCottem turf. And look at the application rates. We've compared 5, 10 and 15% on weight basis application rate of zeolite. If you apply 120 gram per square meter of TerraCottem turf, you only have 0.033%. So the application rate is much lower, positive effect is higher, and you can imagine that the application price is also much lower because application rate is very, very limited. A similar graph on water use efficiency. Water use efficiency of adding TerraCottem turf is much higher than when you add zeolite. Plant available water, remember the PF curve. Positive effect of a single and a double application rate of TerraCottem turf is much higher than adding zeolite. Now this thesis, I've only shown you a small percentage of the results, but the entire summary is available on our website, and after this webinar I will also send you the link where you can download the overall results of the thesis. Please have a look at it, it's interesting. So I want to thank you for your attention, and if you have any questions, I will now unmute you and you can ask me anything you want. So, yes.